Head work, such fun. Got the head back on the bench again. I'm going to give it another run through with the fine grade. And that's because I've had the Dremel with the Scotch wheel on there and I've poked it through every hole, every seat. So I want to ensure that I've got a good seal. Because to do a vacuum test, you've got to have the valves in. And if I put all the valves in and then I find it fails on some valves because I haven't done it properly, I've got to come out again and then I've got to redo it and then put the valve train back in and then retest it. So it's just easier doing it now. So that's the go. Got the valve train sort of right there. So yeah, gonna run through them and redo them, give it a wash and then reassemble it. Finished up on one side, so the other side, still have more to do. So tedious. Just wiped one away there, looks pretty good. So yeah, got the whole exhaust side to do, and then off for a rinse and assemble. Done, finally. So all 24 have been rammed back through with the fine grade and it's a mess again. So I'm gonna need to give it a scrub up and a power wash, and I need to pull those valve spring shims out, or the washers. So they've got to come out before I lose them because they're still in there. They never fell out, they're kind of oil locked in there. So pull them out, clean it, and then reassembly. Fast forward a bit more time again and I have washed the head. I've power washed it, I've cleaned the valves, cleaned the springs and the retainers. It's all nice and dry and it's ready to go. Got some nice silver rings on all the seats, so that means I've got good sealing surfaces. Now I can't actually assemble this at the moment, even though I've cleaned everything up and it's ready to go back in. Because when this gets skimmed, it's going to fling a million chips everywhere. So can't have that everywhere because you've got to use grease to put these in. If you put valve keepers in, you know what I mean. I use assembly lube on the keepers and a flathead screwdriver and that works perfectly fine. But with grease, it's glued for metal. So I have to get it skimmed and then take it back and then reassemble the valve train and then pressure test it and crack test it. And then we should be good. So that is a bit of a pain, but I'm not in a rush anyway because the bottom end's not done. So when I get the block back from Dean, I will be able to assemble that. And in the meantime, I'll return this head to Colin again. Once it's been skimmed, I'll clean it and then assemble it, give it back. And yeah, in that meantime, while I'm working on other things, I'm not gonna be behind because I've got things to do anyway. Things to clean, things to paint, and things to measure. So, gonna get that loaded up in the ute, drop it off tomorrow. I did text Colin and he messaged me back saying that he'd be keen to have a look. So, that sounds good to me. Get it loaded up and get it on its way. Just better do it while I remember. Get rid of the VCT solenoid and this brass 90. That is not going back on. I did mention in another video, got a Franklin kit there. So, gonna use that instead of whatever that kind of contraption is. So yeah, so just pulled these out. The brass 90 just constructed of a male to male and then a female 90 and a barb. Now that's not thread tape, that is grey RTV. I'm surprised it's not red, but yeah, don't use RTV on fittings like that, fuck's sake. Use thread tape, don't be like this guy. Just lovely to see RTV on tapered fittings. It's not like tapered fittings are the seal, of course. So, I'm gonna use that. That is a lot nicer. Franklin Performance 90. It'll do the trick just fine. Got myself a freshly decked 30 block. That's pretty. That brings me to the next job, which is rings. That's the fun part of a build. A ring set here. There's a set of 6. And the fun part with rings is setting gap a million times over. And it takes ages because you can take gap out and you can't put it back. And then it's already been folded from my last build I did. And then yeah, I have to look up, see what ring gap suits my application for just a basic street motor. It's nothing crazy. Not making 900 kilowatt, so don't need to be too crazy. And yeah, go from there, set of feeler gauges. And yep, grind check, that's all it is. Also a few things to do now that he's machined it, which is also number one is to clean it. But all the edges here, the chamfers are sharp, so they need to be sanded off nice and smooth, because you don't want cutting surfaces in a brand new build. I'll grab one of my old pistons that I have, that'll be what I use to center my rings and bring them down to where I need them. And yeah, these need to be sanded smooth, and also you need to sand the rings every time you file them. So I'll get into that in a second. Got a helper with me. Pull the pin out of number 2, and that's what I'll use. So what you do, when you chuck your rings in, you need to center them, obviously nice and straight. And I do it with that. Put them in, nice and tight, nice and straight. Measure them, check them. So set that up in the vise, and check my gaps, and go from there. The rings at the bag, so I've got the top ring here, and these are a molly ring, chrome molly, and they're a barrel face type. Just rounded on the edge, and the second ring doesn't have the little groove that some others do. So it has Eric's on the side, and the same with this one, because they are, well, directional, piston rings are. And you've got your oil control ring, and then your spacer rings. Now, I'm going to chuck them in the bore and see what they measure up right now, and go from there. It might be a bit hard to do with one hand, but I'm going to make sure your rings are upright. You got your dot, the T, or the R, or the word on there. Just want to sit it in there and pop it in. Definitely two-hand job. So use 2 hands, because if it flings out and you damage it, you got to buy your ring set. Now you take a piston, spare piston, or one you're actually using. And what you do is sit it in there and square it up. So you push it down to, well, wherever you want, wherever it's flat. And you go to the skirt right there, and you see that it's perfectly level. Pull your piston back out, set it aside. Now you've got a perfectly squared ring. The whole thing to check when you're actually doing rings is to check your concentricity in the motor, or to your, I guess your bore, I should say. So if you had a torch under here, you'd see light leakage between the gap of the ring and the bore. Now there's none on this because, well, I know the motor's good, the bore's are sweet as, so we're all clear. But if you shine a light under here and you see light come through this gap in here, you need to go oversize. The ring grinder set up in the vise here. Now these 2 points on it, these are for locating your ring. And the first thing you want to do is make sure you've actually got it upright. So make sure your word there, or your letter, or your dot is in there and upright. And pick a side. I mean, it really doesn't matter what side you do, that side or that side. But if you pick one side, you make sure you stay grinding at the same side the entire time. But remember that you can always take material off, but you certainly can't put it back. So grind slow amounts at a time, check it, grind more, check it, grind more, check it. So once you go over, That's it. You gotta put up with the new ring gaps or buy new rings. Running rings, I like to just have a little bit of pressure on each side, just so it holds it down and doesn't jump around or chatter. And you also don't want to push hard. You gotta let the tool do the work, because if you push too hard and you start grinding and you chip a ring, that's it. Back to the drawing board again. Gotta buy another ring. So take your time, let your machine do the work, and it should be sweet. Well, fast forward a day here. So yesterday I did the top ring and then half of the bottom, and I left it because the mate come around and did some fab for me. So I'm gonna run back into it. For the ring gap, I don't think I went over it. So for a rule of thumb, it's per inch of bore you go 0.0045 of an inch. So if you work out an 86mm bore, it becomes 3.386 inches, and then times your, well, 0.0045 is about, I think, 15 thou. Now I've gone to choose 18 thou on top ring and about 21 or 22 on the bottom. So that gives me a bit of leeway. So I've even asked Jens, he's over at Precision Regrinds in Nelson, and he said the same thing. Minimum is 0.045 per inch of bore. So I've got myself some leeway there. It's not loose, it's not tight, probably just where you want it. So now I'm gonna do all the rings, so all top rings, all bottom rings, and then make sure the oil rings are a minimum of 15 thou. Where I got to, so that's the second ring in there at the moment. I ended up with about 14 thou, so I've still got a bit to go. So rip it out and keep grinding. Every time you check and you get your gauges, you just gotta make sure it's not a real tight fit and it's not a loose fit. That slides in there just nice with a little bit of resistance. So that makes that a 15 thou or 0.38 gap. Now I've got it zoomed in quite a lot there, but on that closest ring, there's that little burr on the edge, right at the top, where the metal's folded over. You've got to look out for it when you're putting your rings in your motor. So ideally, every time you file a ring, and you got to put it back in your bore to check it, you need to file that off. Now, I don't have a diamond file or use a little nail file, but I don't have one. So I just use a tiny little bit of sandpaper, just burr the edge over, make it nice and smooth, and then you won't be scratching your fresh balls up. So you just honed them, and then you're putting rings in and out, and scratching them. You're not really gaining any ground, so that's what you can look out for. Just like that, nice and smooth. Ring centered, give it another check. There you go. 19 thou, 0.48. So, still got a bit more to go. So I'm trying to get to there. These are probably one of the things I hate the most doing a motor. It's not even cleaning it, it's not anything else, it's doing ring gaps. It's just such a pain. Now I only use this little tool. Trade Me, AliExpress or eBay or wherever you get it. It's just a basic manual ring file. But if you're a baller, you can go buy an electric one. Now it's kind of like a big rotary tool. You sit in there, you switch it on, and it's also got a dial indicator, so you can actually see how much you're shaving off each time, which is pretty sick. So if I was a baller, I'd get one of them, but I'm a touch of a tight ass, so I'll just stick with my $50 file instead of spending 600 bucks. Get your ring back out, chuck it back on, and keep grinding. It's never ending. So I've just cracked it, got a 22 thou feeler, which is almost 0.56 mil. And there you go, sits in there, perfect. So that's number one, top and bottom ring done. Pop that ring out of that bore, sit it there. Now, got to check the oil spacer rings. Remember to number your rings as well. You have to essentially number them, but you got to keep them in order. So this is bore number one, top and bottom ring, and then now I've got the oil spacer rings. So I need to grab these two, the thin ones, and check these. You don't need to do anything to these at all. Don't grind them, don't touch them, just leave them. Same process for this one as well. Chuck one of your spacer rings in and set your piston in. I don't have to do it with two hands, because if I drop it, it'll go straight through the bottom. But be wary of that. Your top and bottom ring can be, well, they can support the weight of your piston when you drop it in. But these spacer rings are so thin, if you let your piston go, it's going straight to the bottom and breaking that ring. But the spec for your oil ring, it should be the same on most motors, but 15 thou. If you have anything less than 15 thou of clearance, gotta grind it. Now I've done, I don't know how many ring sets, but I've never had to grind a set of oil rings. So you're usually pretty sweet. All lined up, all square, chuck it in, and there you go. That's 15 thou, easy. Probably more like 16, 17. So yeah, usually just a double check. I've never had to grind a set, but you know, machines make errors, so whatever. The second ring there as well, or sorry, the second spacer ring. Takes a 15, no problem. So we're all good here. That's bore number 1 done. Now, the thing that sucks is you got 5 more to do. Sake of not getting them wrong, you can't never be too sure. Number 1, I'm gonna write it on my bench like I usually do. There you go. That's how you do a ring set for an RB30 or any motor. This is just on a 30. So yeah, got 5 more to do now. So I'm gonna get on with them. It's probably not even much point filming them because it is not interesting to watch someone file rings. It's pretty boring and repetitive. So I might as well just smash the rest out and then show it when I've done them all. The 6th and final ring set. So 5 down, better crack open the 6th. Gets quicker when you do it a bit more often. 5 I've just done. Every single one is 18 thou top, 22 thou bottom, and all the oil spaces are a minimum of 15 thou, so we are in the clear. Get cracking on the last one then. Grab the top ring and we're almost done. All done, all 6. Every single ring, 18 thou top, 22 thou on the bottom, and a minimum of 15 thou on the spacer rings. Marked it here on the bench, all numbered. Now I'm gonna have to whip down and go see the local postie man. He's got the ultrasonic cleaner. I want to run these through him. I'm gonna file them down, make them nice and smooth, and then run them through the cleaner, and then I'll run the rods and pistons through the cleaner. Assemble them and pull the pins out of the pistons and everything. Same with the original set. Make sure it's all nice and clean, and then re-lube it all. It's gonna run through water and whatnot, detergent. I kind of want to get it out before I start it up. The old Permatex Ultra Slick goes good, lasts ages as well. I need that too. I've got to grub screw that crank. It's been fully machined, so yep. Dean ground it down for undersize. He also ran over the front and rear main seals to clean them up because they get wear grooves in them. Now that's from when you don't change your front and rear mains. Even if they're not leaking, you should change them anyway because they go hard and they actually cut your sealing journals. So it's had the crank collar put on as well. Nice wide drive. So that's about ready to go in after I grub screw it. So that's the next thing to do. The crank's sitting on the bench here and it's time to grub screw it. So the first thing to do, I'm gonna have to punch these plugs, get the center point, and then drill them out. Now I can't find half my drill bits. The biggest I can find is a 4.5, and I think the holes are a 6 anyway. So hopefully it pulls out and then I can tap straight in. See how it goes. Started drilling into that one there. Now, the drill bit's a bit blunt, but it might work. What I'm gonna do is poke something through the middle here in this journal, your file or Allen key or whatever you've got. Because when you drill it, and if it pushes through, you don't really want it jamming down into the next journal, because you may have a hard time getting it out. So poke that in there. It can only end up at the end of whatever you jam through it. Yeah, so just drill it through and it should pull out with a bit of luck. And there you go. So with a bit of persuasion, a 4.5mm bit, you can get them out. Pretty good because I don't have to drill this any bigger. I don't believe I have to check that hole size. And now I know the hole plug's out, I don't have to go digging for it. And obviously nothing's dropped down there very much. You'll get shavings through it, but that's what you got to clean it for. So that's one of, well, quite a few. Just checked it there. So that's 6mm, and that's not bad. 'Cause for an M8 by 1.25 tap, you need a 6.5mm hole. And for 0.5 mil, that's no worries. You can work around that. It'll still cut through it. Now I've done that one there, I'm gonna run through the rest of them. So I'll quickly do all them. And then when I've got them all out, we'll get to tapping them. Another one. You've done one or two, you get the groove of it. Now, I've done quite a fair few amount over time, so you know the groove for it, but get in the habit, chuck something through to block it, drill it out, and then make sure you get the plug out. If you don't see this plug, it means it's either pushed against the file or it's kind of all balled up. Now, you'd literally just keep drilling until you can feel it, because the file is hardened, and you would know when you're hitting that. And there's been black lumps of dirt in every one I've pulled out so far, just like that little pole down there. So I'm gonna push some out of this one, just so you can see what's behind it. Might be a bit hard to do, because there's not really anything blocking through here unless I jam this in here. But if you poke this through here, you can see the amount of carbon and garbage. It's very soft to touch. I didn't get much out that time. You should see that hole block up. All that there is carbon and garbage and oil sludge. Put it on the end of the spanner there. So that's what you're dealing with. Now that's only a little bit of what was actually in there. And that's all when you crank. So if you think you've ever got it clean, I promise you, you don't. Because that is in every single journal. So yeah, that's why you do it. Because sometimes you don't quite realise how much dirt is actually hiding in places that you can't see. So in the oil gallery feeds in there, in the crank journals, everywhere. Oil, sludge, dirt, carbon, it's all hiding and you can never find it unless you're drilling for it. You get that peace of mind, you've got a brand new fresh motor and everything's clean. There's no garbage in it, nothing come out. Over time when it slowly starts to break down, all your detergents and your oil, new oil with your detergents and stuff, it will break it down at some point and it just runs through your motor. Like sure, your oil filter would catch it, but fully sick V6 Skyline going off in the background there. But yeah, if you can clean it out, you've got a mint motor, just like it rolled off the factory line, you got a peace of mind. Yeah, so I believe I've only got probably 3 or 4 to do now. So I'll finish them up and then get a tapping it. Got a bit more out there, and that's just from one journal. Now that's probably only a little bit to come out. The rest is half sitting on the bench. And it doesn't look like much, but when you got to think your oil tolerances, well, it depends what you run, but I go 0.06 and a human here is 0.07. You got to think there's a lot of garbage just sitting something that tight. Last one. There we go. Should now have a crank with every single gallery bung drilled out. So they'll all come up like that. If you keep your drill bit straight, you would have pulled the plug out and not drilled into the cast iron. But if you did, no worries. The next plan of action is tapping. So I'm actually gonna have to go search for my M8125 tap because I have no clue where it is. Well, I have hit an unfortunate dead end because I can't find my tap set anywhere. What I'm going to have to do is clean this block up. There is shit everywhere on the inside of the crankcase and oil and garbage and all that from Dean. So I'm going to clean this block up. I'm going to get real mint, give it an oven cleaner bath on the inside, power wash it, power wash every hole, all that, and then I'm going to have to dry it out, give it a quick oil coating and wrap it up in Glad wrap. And then on the Monday, I'm going to have to steal a tap and die set. I'm going to go through every single hole in this entire block and clean them up. Because they do have paint in them and half of them have rust in them because this, well, it's been sitting for 10 years. So that's going to be the go for now until I can finish that crank because I can't put this bottom end together. There we go, block's all clean. Just had a power wash, been through every single hole in the crankcase, all the bolt holes, everything. And then I've gone and covered everything in WD-40 so it doesn't flash rust. All the balls are covered, deck's covered, main journals, all that. Next plan of action is freeze plugs. So now it's clean, I've washed it all, ready to go in. because before I wanted to wash all the stuff out of the coolant jackets. So yeah, Aero fail set here, 30mm and 22 are the ones I'm using. There is a 50mm, I'm not sure why. I only ordered a block kit, so that's probably for a single cam head. So I don't need that. And I'm going to punch them in. I don't have a HRB freeze plug set, or freeze plug punch I should say, from Hughes Race Built. So I'm going to use a 1/2 inch extension and just 1/2 inch sockets. That'll work perfectly fine. Simple as that. Push it in by hand and then smash it in and it stays. Can't go wrong. All done. Looks so pretty. Black block, fresh plugs, nice and silver, clean deck, fresh bores, highlighted stamping on the casting. Next thing on the list, real quick one, block restrictors. So VCT, that doesn't have it because it's a 30 block, they never had VCT. Then you should be a 2mm and a 2mm. So I'm gonna go block and then 1.5. That's obviously just gonna help with not pulling the head with oil, which is why my 32 blew up. That's why the 20DET gave up, is because the head filled it with oil and starved the sump. Now it's not gonna drain the sump, but it's gonna help just not accumulate in the top end. So yeah, there's a bit of a guide for different things, so try to put a photo up around here somewhere. And that is kind of the baseline. Circuit, drag, track, street, 30, 25, 25 no VCT, 20, all that. Everything's got a kind of different combination, different pumps. And I'm also using just a standard non-N1 pump. So that's what I'm running with. Took me a hot minute to find the restrictors, but here we are. So what you want to do is punch these down real quick with a flat end punch. So you just want to smack that down a bit, like that. What you're going to do, put it in. There is a tapered side, so put the tapered side downwards and give it a little smack out. You want to get it just a little bit past the deck face, like that. Just to closer up. So it's just barely below the deck surface, and the reason why you do that is to boo the end of the, or boo the edges over. So if you carefully come in and just tap the edges in, had the punch got a little off course, so it's giving it a scratch, but It's not a crucial area between the head bolt and that jacket there. And the next one's exactly the same. So punch it all the way down and then throw in your tapered side in and bear it over. Just switch to a finer punch. There you go. That's all there is to it. So there's a 1.5 at the back, block off in the middle, and no VCT on the front because it'll be fed through the outside port and then up to the head. And I've just cleaned that one up there because I wasn't happy with it, and now it's all good. And there you go. That's how you put restrictors in a block. Probably going to leave it there for this one. I don't quite know how long it's going to be. Might be long, might be short, I don't know. But yeah, next one I'll be chucking the rotating assembly in. So I have to dive more into, well, double checking the machine shop's clearances. Now they should be sweet. I did watch Dean do it by hand, but you should always double check your machine shop's work because people make mistakes. You never know. It's better you find it now than when you put it in and it's been done wrong or for whatever reason or, yeah. So throwing it back together, measure it up, then I should have a fully complete RB30 short block.